Hello everyone, so I am back with the second video of the video series on combustion and flame class 8 science, and in this video we are specifically going to talk about the criteria for combustion, and we will also look at few other important aspects like fire control. So are we all excited to learn with me? Let's get started.
Do you think that combustion can happen just any time we want? So a substance, maybe a paper, will just start burning on its own anytime? Had that been the case, then every time it would have been fire everywhere and everything would have got burned by now. But that doesn't happen, right? For a paper to catch fire, there are certain criteria which needs to be fulfilled. So only when those criteria are fulfilled, only then the process of combustion actually take place. So here we will talk about those three important criteria without which combustion can never happen. And what are the three criteria? The first is a fuel. A combustible substance is needed, because until and unless you have a combustible substance, so obviously which object will catch fire? So you need to have a substance which easily catches fire. You need air. Why do you need air? Because as I mentioned before also, that oxygen is extremely important for combustion to take place. What happens during combustion? The substance reacts with oxygen. So without oxygen there will be no reaction, there will be no energy released. And the third criteria is heat. Now the question is, why do we need heat? We need heat because we need to increase the temperature of the substance to a particular temperature so that it can catch fire. Now we are going to talk about each of these points in more detail one by one, and we will see that how each of these criteria is important for combustion to take place. Now the first point, that is combustible substance, this we have already discussed, that not all substances readily burn. So those substances which easily burn to produce a lot of heat and light, they are called combustible substance, and one such combustible substance has to be present for combustion to take place. So now we will talk about the second factor, that is air. Why is air necessary for combustion? Now in order to understand this, what we will do is, we will do a small experiment, or we will do a small observation rather. So for this, what we need is a candle which is already lit. So with this lighted candle, what we do, what do you see right now? So the candle is lit and it's like perfectly, it's glowing. The flame is seen distinctly. Now I take a glass and just put the inverted glass over this candle. What happens? The candle still glows for some more time, but after some time, it goes off. The flame goes off. Why? Why did this happen? Because we did not do anything to blow off the candle. So, whatever you observed till now, just do one thing, just note down the time for which the candle was lit even after the inverted glass was put over it. Initially it was glowing, we put the glass, it still glowed for some time. So let's note that time. So let's say it glowed for some time, say t1 seconds, and after that it went off. So why did it go off? Because when we have put this glass, we have actually limited the amount of air which is being provided to the candle. When the glass was not there, there was plenty of air surrounding the candle. So it was utilizing the air and the process of combustion was taking place. But now when we have put this glass, so it is only that much amount of air which could be accommodated inside this glass. So only this much air is available to the candle. So the candle utilized all the air which is present inside this glass. But after that, there is no air. When there is no air, there is no oxygen. When there is no oxygen, no combustion can happen. And therefore, it just went off. Right? So that's the first set of experiment which tells us that air or oxygen is necessary for combustion. Now we will do little more experiment with the same thing. Now what I do is, I take the same candle, but now I change the glass. I take a bigger glass. So when you take a bigger glass, what happens? Again, the candle will glow for some time, and note down the time in this case. So let us suppose this time, the time is say T2 seconds. Now what you will observe here is this time, the time for which the candle was glowing before it, again obviously here also it will go off after some time, because again here also we have put a limitation, so it can only utilize the air which is there inside this glass. But what we observe is T2 is greater than T1. That means the time for which the candle lighted in the second case is more than the time for which the candle was on in the first case. Why? That is because in the second case the glass was bigger. Second case it was a big glass, and in the first case it was a small glass. So when the glass was small, there was less amount of air. So there was less amount of oxygen available. So therefore the candle could light only for some time. But in the second case, the glass was bigger. So larger amount of air was present inside the glass. So larger amount of oxygen was present. Therefore the process of combustion could happen for a little longer time, and therefore the candle lighted for a little longer than case 1. So this experiment further proved that yes, air plays a very critical role for combustion. Again, if you want to experiment with the same apparatus, what you can do is maybe you can just lift this glass a little bit upwards. So when you lift it a little bit upward, what happens? A gap is created here. Now, right now the glass is placed inverted on the surface or on the table. But if you lift it a little upward, what happens is a gap is created here. So some amount of air will enter through these gaps. Therefore, in this case, the candle will not immediately go off. Instead, it will start to flicker. And why the flame flickers? The flame flickers due to limited supply of oxygen, or due to insufficient supply of oxygen. So these experiments prove that air is very, very necessary for combustion. In fact, you can try out this experiment also. You will find it interesting. You will say that in one case, you take one candle and cover it with an inverted glass. In the second set, instead of one candle, you take 3 candles and cover it with an inverted glass of the same size. Now, what do you observe? In the first case, the candle glows for some time and then goes off. And in the second case also, all the 3 candles, they glow for some time and then go off. So let's suppose in this case, the time for which they remain lighted after the glass is being put is T2. And in this case, let's say it is T1. So in this case, which will be more? In this case, we will see that T1 is greater than T2, because here the amount of air which is available in both the cases is same, because the glass is of the same size. But in this case, there is only one candle to consume that air. But in this case, there are 3 candles to consume oxygen from that air. So the contenders are more. Therefore, each of them get only 1/3 of the air which is present inside the glass. Therefore, the candles go off faster than in case of the first scenario. So it is seen that a single candle burns for longer time than 3 candles when covered by the same glass. So all these experiments with candles and glass proves that combustion cannot take place without air, without oxygen. Now the third criteria, that is heat. Why is heat needed for combustion? Now, before we talk about it, let us think of some simple scenarios. So think of the matchstick. How does a matchstick catch fire? Does the matchstick catch fire on its own? No. We need to put in some effort. What do? We have to strike the matchstick against the rough surface of the matchbox. So only when we do that, it catches fire. Why do we strike it? And why is that needed? That is because when we strike the matchstick with the matchbox, there is friction. And friction produces heat. And when this heat is produced, it increases the temperature of the matchstick, and when the temperature increases, it catches fire. So basically what this example tells is any combustible substance catches fire only when its temperature reaches ignition temperature. Now you might ask, what is ignition temperature? So we will talk about it just now. So it basically means that it is not that any substance will catch fire just any time on its own wish. So the substance will catch fire only when its temperature reaches a particular temperature. So in order that the temperature reaches that temperature, it has to be provided some heat. Only then the temperature will rise, and that is why heat is needed for combustion. So ignition temperature is the lowest temperature at which a substance catches fire. Now ignition, the word ignition has come from ignited, to ignite something or to burn something or to make something catch fire. That is ignition. Now this temperature is not same for different substances. Every substance will have its own ignition temperature. There will be some substances which will have very low ignition temperature. So low ignition temperature means they will very easily catch fire because already the ignition temperature is low. It is like your passing marks. For example, in your school, the passing marks is 40 out of 100. In another school, the passing marks is 30 out of 100. So if the passing marks is lower, if it is 30, then it is easier to pass. If the passing marks is say 60, then it is more difficult to pass. In a similar way, if the ignition temperature is very less, it is very easy for that substance to catch fire because that temperature where it gets ignited is very less. If the ignition temperature of a substance is very high, then it will not catch fire easily, right? So what do we say is substances with low ignition temperature catch fire more easily. So now I think you will be able to understand why do we need to strike the matchstick. Because when you strike the matchstick, friction is involved and friction produces heat, and this heat increases the temperature of the matchstick so that it is able to reach its ignition temperature. Now you might ask, is the matchstick a combustible substance? Of course, because if you look at the head of the matchstick, it is made, do you know what is one of the most important constituent of the head of matchstick? It is phosphorus, and phosphorus is highly reactive. It reacts very violently with air to catch fire. So now it is not only phosphorus which is present, small amounts of sulfur and potassium chlorate is also present. So we will discuss about how exactly matchstick works a little later. So for now you should just understand that heat is important for combustion. So a substance will not catch fire or it will not undergo combustion on its own. So every substance will have an ignition temperature. Now, and in order that the substance reaches that ignition temperature, external heat needs to be applied to that substance. So this is how we found that three criteria are very important for combustion to take place. That is a combustible substance, heat, and air. So let us look at some more examples of different substances with different ignition temperatures. So if you look at this screen, you see on the first example, you see paper is the combustible substance. And in the second example, you see wood is the combustible substance. Now, which of these do you think catch fire easily? So if you bring a small matchstick which is burning near a piece of paper, what do you see? It immediately catches fire. Why? Because the ignition temperature of paper is comparatively lower. Now, since the ignition temperature is lower, as soon as you provide little bit of heat by bringing the burning matchstick near it, it reaches its ignition temperature and it catches fire. Whereas if you consider few logs of wood and if you take a tiny matchstick near that, it might not readily catch fire. Whereas if you take this burning piece of paper in front of these logs of wood, then it will catch fire because that entire burning paper will give more heat, will provide more heat to the wood. So, and because the ignition temperature of wood is little higher, so they need more heat to reach that ignition temperature. So if you actually look at the values, ignition temperature of wood is somewhere around 300 degrees Celsius, and the ignition temperature of paper is somewhere around 218 to 245 degrees Celsius. So that's how roughly the ignition temperatures are for paper and wood. So whichever object will have a lower ignition temperature will easily catch fire. Now when we talk about ignition temperature, it becomes very important to talk about two important concepts. One is flash point, the other is auto ignition temperature. Now what are these two and how are they different from each other? Now there are two things. Now any combustible substance, one way is the substance is so highly reactive that it can catch fire on its own. So just that if you heat that substance, it will immediately catch fire on its own. The second thing is the substance always need a source to ignite it. For example, certain things need something else to initiate the process of ignition. So when we talk about flash point, it is the lowest temperature at which a substance can vaporize to form an ignitable mixture in air. So in case of flash point, an ignition source is needed. So you need an external substance in order to start the process of ignition. So let us take this example. For example, if you think of kerosene. So kerosene is a combustible substance, right? So if you talk about the flash point of kerosene, it is somewhere around 38 to 72 degrees Celsius. That is the flash point of kerosene. Now what do we mean by flash point of kerosene? Now if you compare the flash point of kerosene with that of wood, so if you look at the flash point of wood, it is quite higher when compared to kerosene. Now since wood has a higher flash point than kerosene, therefore kerosene catches fire more easily. Now if you have two scenarios, in the first scenario you have few logs of wood, in the second scenario you have few logs of wood with kerosene spilled over it. So which of these two will catch fire easily? The second one, because it has kerosene and kerosene has a lower flash point. So it will very easily get ignited when an ignition source is there. Ignition source means maybe you bring a matchstick near it. So that matchstick acts as the ignition source. So the kerosene will get converted into vapors, and during this vaporization we see it as fire. So that because that is an ignitable mixture which is seen in the air. So this flash point actually indicates the combustibility of a substance. So whichever substance has higher flash point, its combustibility is little lesser. Now similarly, if you look at the flash point of diesel, it has a flash point of around 52 to 96 degrees Celsius. Now why do you have this range? That means anywhere between these two temperatures, maybe in any temperature between 38 to 72 degrees Celsius, kerosene can catch fire if there is an ignition source present. Now on its own it will not catch fire at these temperatures. So at these temperatures it will catch fire only if there is an ignition source present. Now the next concept is auto ignition temperature. Auto means self. So anything, ignition which happens by itself, that is auto ignition. So it is the lowest temperature at which a substance ignites spontaneously. So in this case, you really do not need an ignition source. You do not need external ignition source. So when a combustible substance reaches this temperature, it will ignite on its own. Suddenly it will get ignited. Now, when you look at the same kerosene, So we saw the flash point of kerosene, which was somewhere around 32 to 70 degrees Celsius. Now when you look at the auto ignition temperature of kerosene, you see that it is somewhere around 295 degrees Celsius, which is very high. So what does this mean? This means that kerosene has a flash point which is in the range of 38 degree to 72 degrees Celsius. That means within that temperature range, it can get ignited if there is an ignition source present, only with an external ignition source. But if there is no external ignition source, kerosene by itself will not catch fire until and unless it has reached a temperature of 295 degrees Celsius. So let us suppose there is no external ignition source, there is no matchstick, nothing. But if you start heating kerosene such that it reaches a temperature of 295 degrees Celsius, then it will automatically get ignited. So it will catch fire on its own. So that is why this temperature is called auto ignition temperature. So please understand the difference between two. Flash point is only when you have an external source which can make that object catch fire. And auto ignition means you do not need any source. Once the object is heated to that temperature, it will catch fire on its own. So here no external source is needed. So no ignition source is needed. So let us look at few other examples. So take example of coal. So the auto ignition temperature of coal is around 500 degrees Celsius. That means if you heat coal to this temperature, coal will catch fire on its own. And that is what happens in so many coal mines. We have discussed about coal mines, right? Coal formation takes place deep under the ground. Now wherever you have huge coal mines, now since the temperature deep inside the earth is very high, so sometimes what happens is the temperature increases so much that it reaches around 500 degrees Celsius, and that is when coal gets ignited spontaneously on its own, and that is how we have coal fires in the mines. You take example of wood. So in case of wood, this auto ignition temperature is around 300 degrees Celsius. So if wood is heated to 300 degrees Celsius, it starts to release hydrocarbons which react with oxygen in the air, and that's how it catches fire. So whenever we talk about auto ignition temperature, it is a temperature to which if you heat a particular combustible substance, then that substance will catch fire on its own. So that is auto ignition temperature. So auto ignition temperature also tells us, or it also indicates the combustibility of a substance. So a substance which has a higher auto ignition temperature, so that substance will not catch fire easily. For example, if you compare coal and wood, so if you heat both coal and wood, so which will catch fire faster? Wood, because as soon as wood reaches 300 degrees Celsius, there only it will catch fire. But for coal, it can go beyond 300 and it can go up to 500 degrees Celsius. So any object, so both these things, flash point and auto ignition temperature, both of these indicate the combustibility of substance. So knowing these values, we can predict which substances will catch fire more easily than others. And knowing combustibility of various substances, we can choose each of them for various purposes. For example, I'll give you some common examples. In the cylinders which are used in our kitchen to prepare food, so what kind of fuel do we use? Do we use coal? No. What do we use? We use LPG. Why? Because if you look at the properties of LPG, so this is another fact that LPG also has many advantages, like it does not cause pollution and it is a clean fuel and etc. But other than that also, when you know the ignition temperature and the flash point of these fuels, you can actually decide whether this fuel will be suitable for this purpose or not. Because when you are preparing food, you deal with a specific range of temperatures. So when you are keeping the cylinder in your house, so that cylinder is exposed to the room temperatures. So basically you can decide whether that particular fuel will be suitable for that purpose, knowing its auto ignition temperature and flash point. So now knowing this concept of auto ignition temperature and flash point, we will see that how water helps to control fires. Have you ever seen that if a building catches fire or if a shop catches fire, what happens? People call fire brigade, and what do? they try to put off the fire using water. Now, why water helps to extinguish fire, and what is that property in water which helps to get away with fires? Now, water cools the combustible substance. Now, we saw that there are three criteria of combustion, right? What were the three criteria? The first criteria was a fuel or a combustible substance. The second criteria was the presence of air or oxygen, and the third criteria was the presence of heat, so that the substance can reach its ignition temperature and can catch fire. Now, if we want to put off the fire, so let's say something has already caught fire, but now we do not want that fire. So how do we put off that fire? If any of these criteria is not fulfilled, there will be no combustion, so there will be no fire. Now, what does water do? Water is quite cold, and therefore whenever you put water into over a hot substance, it reduces the overall temperature of that substance. So basically, instead of providing heat, you are actually making the substance more cold. So you are reducing the temperature of the combustible substance. Now, when you reduce the temperature, so what happens? Again, the substance temperature comes below the ignition temperature. So below the ignition temperature, a substance cannot catch fire, and that is why the fire it doesn't catch fire again, and that's how the fire stops. Because what is fire? Fire is nothing but a result of reaction of the substance with oxygen, right? So right now the substance is still in contact with oxygen, but it is not able to release enough energy because it has not reached its ignition temperature. So that is how the fire is put off. So because the temperature falls below the ignition temperature. So using water, this criteria is not fulfilled, and that is why there is no fire. And that is how the concept of water as a fire extinguisher works. Now, water cannot be used as a fire extinguisher in all the scenarios. For example, if you take example of spaces where there are a lot of electrical equipments or electrical wires, for example, in office spaces where you have a lot of computers, lot of machinery, factories or industries where there are a lot of electrical equipments involved, water is not a good choice as fire extinguisher. Can you tell why? Because when I am talking about water, I am not talking about pure distilled water. I am talking about normal water, which contains dissolved mineral salts, etc. in it. So this water is a good conductor of electricity. So normal water. So when I say water is a good conductor of electricity, I mean not pure water. And the normal which we use in our day-to-day life, that is not distilled water. So this water is a good conductor of electricity. Now, since it is a good conductor, so what happens is when you put water on electrical equipments which has caught fire, so the chances of getting electric shock is very high, because water will also start conducting the electricity, the electric current which might be present on those electrical wires or the electrical equipments. Therefore, water is not at all a good choice to be used as fire extinguisher in fire involving electrical equipments. So which is alternative choice? The alternative choice is carbon dioxide. Now, what special is there in carbon dioxide that it can control fire? Because carbon dioxide cannot act as a cooling agent, but it can do something else. So what carbon dioxide actually does is it acts as a blanket over the substance which has caught fire. Now this fire, as I again said, there are three criteria, correct? The first criteria for combustion is fuel, second criteria is oxygen or air, and third criteria is heat. Now water acts as a fire extinguisher because it attacks the third criteria, but carbon dioxide attacks the second criteria. Now because carbon dioxide is a gas and oxygen is also a gas, this carbon dioxide is heavier than oxygen. So carbon dioxide is heavier when compared to oxygen. Now since it is heavier, so it settles down. So as a result, what happens is carbon dioxide acts as a blanket surrounding this entire substance. So let us suppose this is a wire. Just an example, this brown colored line which you see, that is a wire and it has caught fire. So over this wire with fire, the carbon dioxide will act as a blanket. So here you will have the carbon dioxide blanket. And where is oxygen? Oxygen is present in the surroundings, so maybe oxygen is present here. Now basically if you see, due to the presence of this blanket of carbon dioxide, the contact between oxygen and the substance, this is the substance. So the contact between oxygen and the substance is being cut due to the presence of carbon dioxide in between. Now since the supply of oxygen is cut, therefore there is no oxygen supply, so there is no combustion, so there is no fire. So that is how carbon dioxide acts as a fire extinguisher. Now how do we actually, for example, in case of water, we just bring water maybe in buckets or in pipes and we try to extinguish fire. But how do we do it with carbon dioxide? So carbon dioxide is present in liquid form in fire extinguishers. If you look in your office spaces, you will see the red colored fire extinguisher boxes. Inside that you have carbon dioxide in liquid form, and when it is released, it neutralizes the oxygen that is actually causing the fire. So another advantage of using carbon dioxide as fire extinguisher is that fires do not recur immediately because of lack of oxygen, because all the oxygen is being sent out by carbon dioxide. So it actually neutralizes with the oxygen. So there is no more oxygen surrounding the substances, and as a result there is no fire. In fact, the carbon dioxide which is directly released from the extinguishers, that is also at ice cold temperature. So it is extremely cold. So there are certain precautions which need to be followed while applying carbon dioxide on in office spaces which have got fires. So what we learned is we can control fires either by using water or by using carbon dioxide. But the basic concept of controlling fire is that one of the three criteria needed for combustion needs to be limited. That is, one of those criteria need to be falsified, and then combustion cannot happen, so there will be no fire.
I hope you found the video useful. If at all you have a feedback to share, do let us know in the comment section. And if you liked the video, do not forget to share it with your friends. I will meet you all very soon with a new topic, with a new video. Till then, take care. Bye-bye.